to be a possibility to have
Well,
a rotating mesh?
actually, how it works is we're emulating the fluid actually rotating, not the component itself.
Oh, okay.
So just the fluid domain around.
Yeah, so I did that. I guess I didn't quite understand. So, but when I ran the simulation, it didn't look right at all.
Okay.
So
I'm just gonna mock up this. Again, the whole purpose of this is for stability. So you mock up a hollow cylinder on the inside face of the cylinder, apply environmental pressure condition.
okay.
And the whole purpose is to help stabilize the cow. I'm just gonna draw something similar here.
So you're just doing a circle.
Yeah.
You're just sketching on the front plane.
Yep.
Okay.
Keep it easy there. Work with.
So you got.
Close to the boundary.
Do you want to do pretty far out, or like when you're setting up that circle, you want to have like a pretty
You
good.
don't want it too close to the object. It'll kill the mesh.
Okay.
You have to get the mesh cell size quite a bit smaller.
Okay.
You want about I go off memory here, about 5-6 cells at least from the outer edge of the blade, the outer leading edge, and out to the boundary of the cylinder.
Okay.
So I'll probably scale this down a bit. Just look at it. That'll probably work. If I water, whatever.
Okay.
Just want to do this. I just come this way, right? Coming in.
Yeah. So
You really just want it.
are you doing both directions?
Yeah, it was in midpoint. Pretty much want it far enough distance in front of it, just so the flow can develop, and it passes well. You don't want to obstruct or.
Yeah. Okay.
A lot of times, kind of guesstimating size, running it, take a look at the trajectories, and see, go from there. But I'm just gonna try 14 inches.
Okay. Cool.
That should be good right there. I'll show it. All right.
Oh, you're shelling it.
Yeah, so I uncheck merge result, and then I still have two separate bodies there. I want to make sure to shell the cylinder and make it doesn't matter if it takes too much.
Where is the shell?
Features.
Features. Oh, okay.
I'm trying to go with default 0.1 inches is fine.
Okay.
Let's make this transparent.
Yeah. Now, so I was trying to model up a tube, just a straight tube
Yep.
to run a flow through, and it said the ends needed to be capped.
Yep.
How come?
Well, it needs to be able to define the fluid domain.
Okay.
So
So.
it has to understand, what is the volume of the flow.
Oh, I see. Okay.
In this case with the shell, it doesn't have to be separate bodies, so I can just pick the inside face of the shell for my boundary condition surfaces.
So how did you just do that?
To the I said section, you just kind of show it.
Oh, okay.
And it made the body transparent just to be able to see through it.
You just picked the right plane for that.
Yeah. Doesn't really matter. Well, yeah, either right or just not.
No, okay.
Actually, top right doesn't really matter. Just a section cutting through it just to show.
So my propeller disappeared.
You have merge result on, most likely.
Where's that?
Go and edit your box extrude too.
Edit feature?
Yep.
Yeah.
Now check box merge result.
Okay, cool.
And then you'll be able to. That was two
I
bodies.
thought I shelled it. Oh, do I need to?
Now it failed because there's multiple bodies.
Oh, okay.
So you just have to pick the body option there. Just gonna
So
pick the
that's
outer cylinder.
this guy right here, right?
Yep. I was picking the graph for you.
Okay.
Then it's okay. That's the next
There we
one.
go. Okay, cool.
And if you want to make it transparent, I'm not sure if you guys play around with the display pane at all. Vicinity here,
Yeah.
multiple
Oh.
bodies, you can adjust the color, transparency settings, stuff like that.
For the,
Just the outer body, just so you can see through it. Are you guys all Solidworks users? You guys play with
Pretty
this?
much.
Yeah, so the feature.
yeah.
You guys been using the S key shortcut, setting the letter S into SAM? It pops a little toolbar. It's been out.
Yeah, I've never
2010,
done that.
something like that.
That's pretty cool. Yeah.
You can right click anywhere on the bar to customize and whatever level you want to
Oh,
customize there.
nice.
Put anything you want, so you can throw out features on your sketch.
Yeah.
Toolbar doesn't matter. So it's not mode specific.
Is it the S key for that?
What's that?
Just hit the S key for that?
Yep. That's the default. You can change it if you want. There's another entity. I don't know if you guys ever seen. Maybe came across it. Right click, a little wheel pops up.
Yeah.
Mouse gestures. You can customize that, so I got a little shortcut bar at the top, each project one. Got that with mine's out. Let's say that. So I'm just gonna step to the wizard. I mean, in terms of creating a project, use a wizard or hit new, you'll create a, it'll just be based off a template. There's only one template in there.
Mm-hmm.
You can create your own. I'll just step to the wizard here.
Yeah, this is what I did.
Yep.
So,
For the wizard, depending on how you want to set things up, you can tell the system to use the current Solidworks configuration and create a new one. Selected configuration, so I'm going to do with current here. Project, I'm just going to leave it as the default name. Unit system,
so you used to use current.
yeah,
Okay.
the default name, wouldn't matter in this case. In terms of the unit system,
We want to
guys working
do
with?
the metric.
okay, that's how unit
So that's
default
how,
there.
yeah.
Temperature of any concern?
No, I mean it's
Okay.
gonna be in, like the ocean or
Cool.
a pool or whatever.
I was just changing out speed and Kelvin, but I usually change the unit there. But so this is the recount. You could go ahead and pick any unit you want for the sub levels. But
Yeah, we'll probably use Celsius.
so in terms of the rotational velocity, I mean radians per second to default there. You can change it depending on what you're working with. RPMs, hertz.
Yeah, we'll probably do RPMs because you guys are calculating the propeller
Yeah,
velocity
RPM.
and RPMs, right? So,
Okay. For the most part, the rest of this we just leave it the way it is. You can make changes on the fly afterwards.
can we do? What do we do? What do we want to do? The force in the thrust. Do we want to do kilogram of force, or should we stick with Newton meters? Probably stick with Newton meters.
I like
Probably
Newtons.
Newtons. I think that's what Cibotus guys said.
Yeah, they do all metric, so
Okay.
so we'll keep it in Newton meters. Alright, cool.
So in terms of analysis type, in this case, this would be internal since I created that cylinder. So we're just analyzing the flow inside the cylinder.
Mm-hmm.
If you have flow over the object, through the object, you'll go external. Gives you the ability to be on both. It's like in both domains. In this case, real simple setup on this one. There's not much to it. I have two cavities without flow conditions. Won't come into play. Doesn't matter if it's on or off, just because there's only one cavity. There's, I guess the blade's not hollow. There's nothing in, no internal domain. It's just one entity, so it doesn't matter if it's on or off. We were worried about actually taking a look at the blade heating up, turn on heat conduction if needed. So in terms of actually running the calc, there's time dependency or there's a steady state. There's really no steady state solution for anything like this.
Mm-hmm.
It's just based on the stability of the flow,
Okay.
kind of oscillates. So we try to run it as a time dependent, say run for a minute, 2 minutes, and kind of see what happens. Or what you can do is you could set the end condition, say, let's run it for 2,000 iterations or 1,000 iterations, and let it develop and stop yourself. Take a look at what's working with the hard result. Just gonna leave it just off at the moment. Gravity, again, it's really
It's gonna be in water, so I don't know how gravity would apply.
I wouldn't
Yeah.
really think it would apply here.
Okay.
You always worry about that. In terms of the rotational region, the local region would be if I would have to mock up a body of revolution around the entity,
Mhm.
and I would say that's rotating at a certain RPM, and I have to pick it afterwards. There's an option here for global rotating, which gives the ability to specify the entire domain is rotating.
Okay.
I'm saying the flow comes in, the entire entity is rotating. I think the best bet on this one, let's play with this, should actually just go ahead and create a body of revolution around it first. Knock it up to offhand. And I think it would be appropriate, we're saying the entire domain's rotating back here, going through it, so it's one thing I
So we'd have to adjust that though, right?
yeah, I just kind of forgot.
The axis, the rotation.
Oh yeah, if we want
is-
to leave it as global,
Yeah.
that would say the entire domain. So we're talking about the entire internal volume here is rotating,
Oh, okay.
and that's probably it's not going to be appropriate. Just forgot all about that.
But if we were to do it though, we'd have to change
Yep.
the axis rotation. I think it's the
Simply
Z
just-
axis.
Exactly, it's
Yeah.
following the Z here. So
Okay.
yeah,
Yeah.
so let's doing that. But
Okay.
it would make sense in this case